and today we're going to go through temporary works in a rail environment. And as Christian said, I couldn't believe how long ago it was we did the last one of these, and it was 2020. And since then, CPO 3 has been updated at least once, if not twice. So I've had to go back through that and make sure this is the latest version. So for those of you who haven't been on the webinars before, we can't see or hear you. Hopefully you can hear us. If you can raise your hands just to let us know that you're hearing us. Yeah, there we go. His hand's going up. That's good. It's always a good start. If you could use the Q&A setting just there in that red circle for any questions you have, feel free to type them whenever you want during the presentation, and we'll just hold them all till the end and we'll normally answer all of them, but as many as we can. Depends how popular the webinar is. If you put them in there, we can keep track of them. They come up and we can see and we can answer them and mark them as answered or unanswered, and it's much easier than doing it in the chat. The chat gets very chaotic very quickly. So if you can use the Q&A, that would make life easier and ensure that you actually get your question answered. So who are we? We're an engineering consultancy operating out of 4 offices across the UK. Demolition engineering and temporary works is what we do, from rail projects through to commercial, heavy industrial, you name it, we've worked on it. But we do an awful lot of demolition work, which obviously brings us into contact with the railway. A lot of railway bridges demolished. You see the one there, bottom right, Filton Bank Viaduct. So that is what we do. So let's actually get into the presentation itself. So why are rail temporary works different? What's so special about them? Well, the answer to that is, if you get things wrong, not only do you affect your construction site, but you have the very real opportunity to kill or injure a lot of people who happen to be going about their daily life using public transport, in this case, the railways. So as far as I'm aware, I don't think there's ever been a temporary works failure that has actually caused a train carrying passengers to derail that has led to injury or serious injury or death, though there's been a couple of close calls over the years. Going back, I don't know, when Gerrard's Cross was probably early 2000s. I can't remember. They wanted to build a new Tesco store above the railway just outside Gerrard's Cross station. And they did it out of precast segments, which you can see here. So that's one segment. Hopefully you can see. Can you see my mouse moving right? Or do I need to just draw on the screen?
It was 2005, Angus.
2005, there you go. So there's one segment that way, the other one that way. So they sat on foundations over here and here. And then they were dropped into place. And then there was supposed to be a very careful backfill methodology used to ensure that there was a balanced load on either side of the arch. Unfortunately, something went wrong and the arch collapsed onto the railway. It was only through good luck that the train hadn't left and the train driver managed to stop the train in time. There's no reason at all why that couldn't have collapsed on top of the railway. It was just again through luck that there wasn't a train passing underneath when that occurred. This one's fairly recent. I think this was last year. This was during, I think they'd stripped the track off the top of the arches and they were running excavators along. And that caused increased load on the parapet wall. And the parapet, quite a long length of parapet wall rolled over and caused that chaos you can see below there. Are you hearing me okay, Chris? It looks like there's someone saying there's struggle.
Yeah, I've just checked on the chat and it looks like it must just be an issue on that person's audio as everyone else is saying we're coming through loud and clear.
Good, fine, good. And then the bottom one here, again, I can't remember what year this was, but this is the London Tilbury Southend line, so out towards Southend, and a piling rig collapsed across the railway, taking down the OLE. Again, luckily, there were no trains coming past or close enough they couldn't stop. But again, no reason why that couldn't have led to a massive number of fatalities. It's just luck. And that's what we've all got to avoid. And that's why rail temporary works have another level of, what's the word for? Scrutiny, shall we say. That's why Network Rail have a fully formulated system in place for controlling and managing temporary works in the rail environment, because the ultimate consequence is something that impacts a train, which is unthinkable, truly unthinkable if that happens. So the other aspect to consider with the railway is quite a lot of our rail network is electrified, and there's plans for quite a lot more of the rail network to be electrified. You have two key types. You have your OLE, overhead live cable there, which the conductor picks up off. Obviously that's running at high voltage, so you've got quite large interface zones you need to be aware of and stay well outside. So the key one being the 2.7 exclusion zone around the conductor itself. Then you have your EMC interface and compatibility zones. That's more of interest when it comes to building near it or putting a house near it or some sort of development nearby. You need to make sure you're outside the EMC zone. Down in generally the south of the country, south of London, we also have the lines that are third rail electrified. That's literally just a rail that sits here and here, and then, or it could be this side actually, it can be either side of the track, and the trains have a shoe on them that picks up current from there. Now, probably not quite such an issue to work around because it's quite well understood where that is, but the OLE is a much higher hazard for the sort of works we're doing, I would suggest, than the third rail. Unless, of course, you're working on the track, in which case you've got to protect the conductors. So Network Rail defines what they mean by temporary works. There's lots of different definitions in the industry of temporary works, but this is what Network Rail use. An engineered solution that is used to support or protect either an existing structure or the permanent works during construction, or to support an item of plant or equipment or the vertical sides or side slopes of an excavation during construction operations on site, or to provide access. It is used to control stability, strength, deflection, fatigue, geotechnical effect, and hydraulic effects within defined limits. They then go on to talk about a number of specific items, but I'm not going to read all of that out. You're quite welcome to read it or get yourself Civ 03 and read it yourself. So one big change within the industry since the last time I did this presentation is that Network Rail have now made their standards freely accessible to people who need them. So if you search for Network Rail standards, it will take you to a Network Rail page, which will tell you how to gain access to the standards. Effectively, you register, they check your credentials that you are actually working on the railway or you need access to these standards. And if so, you get access and you get all of your standards for free, which to my mind makes an awful lot of sense. These Network Rail documents, it made no sense to me that we had to pay to access them to do work for Network Rail infrastructure. It makes far more sense that they're free issued and we don't just add on the charge of accessing the standards to Network Rail every year. So it makes perfect sense to me to do it this way. And it means there's no excuse. If you need the latest standard, you can go and look for the latest standard, access it yourself, and away you go. So anybody here who's working in the rail environment wants to go and read where this all comes from, there you go, Civ 03 issue 7 is the latest version. So within Civ 03, there is a process flow which clearly explains temporary work, well, permanent and temporary works actually, but we're talking today about temporary works. They've changed from the grip stages at the top, though grip stage is still broadly aligned with these. I'll show what grip means in a minute, but it used to be tied back to the grip stages of the projects, but they've changed. I think they're now using, is it PACE system? I can't remember off the top of my head. So right from the very start, temporary work should be considered. It's quite clear here. So at the very, very earliest stage where you're working out, right, we want to replace this bridge, or we want to build this new platform, or whatever else it might be, whatever the project might be, you're supposed to start considering temporary works. In fact, the permanent works designer has to specifically cover their conceptual idea for construction and temporary works within the Form A, which is the approval in principle process. So it should be being considered right from the front of the project, which is excellent, as long as they get the right people involved at an early stage to consider the temporary works and to actually plan how best to deliver them. I've whinged about this many times before, but if you get people in who know temporary works, then you get a better output at the end than if you get a permanent works engineer to come up with the temporary works. Design stage, there's the detailed design, there's the design check, which we're going to touch on shortly, and the outputs are Form C or Form H. So Form C is for Cat 2 and above. Should also be Form G, Cat 0 and Cat 1 are Form H and Form G, and Form C is for anything above that. Temporary works approved and constructed, you'll have an inspection and testing regime that goes along with that, but then be verified and used, and they'll be removed. And then there's also the Form E, certificate of fitness. Sorry, I've got a very itchy nose. Certificate of fitness to be taken into use, which will have to be filled in, but that's a construction stage thing rather than a design stage output. So just going into a bit more detail there, which I've talked through in the other slide. So the grip stage is what we used to be using, which was output definition, feasibility, option selection, single option development, detailed design, construction, test and commission. These grip stages still kind of go hand in hand with these stages here. It's just they've tweaked the naming of them, but the grip stages are still referred to within Civ 003. Last time we did this presentation, we would have been talking about Form 1 to 6. They no longer exist. So we're now going back to Form A to H. Form A being the first form that's put in, which is the approval in principle, explaining what the project is and how it's going to be done, the design standards you're going to use. Every project for Network Rail will have a Form A because it sets down how the project is or what the project is and how it's going to be designed and delivered. And as I said, it should specifically be mentioned in temporary works within it. Form B is the certificate of design and check for permanent works. Form C, certificate of design and check for temporary works of category 2 and above. Form D, I'm not really sure, I've never ever been involved with one. Form E is bringing something into use. Form F, Roads Highways Authority, again, I've not really got much experience of that. And then Form G is for Cat 1 work, and Form H is Cat 0 temporary works. So these have all been simplified, and whereas before for a temporary works design, you've had a Form 2 and a Form 3, it's now all in one document, which is your Form C, which is only a good thing in my mind. And then this is just, again, this is the Network Rail definition of each of those, showing the design check categories that are covered, which is basically what I've just talked through there. Again, straight out of Civ 003. So within Civ 003, there's a number of what they call it resources. There's people involved, and it clearly sets out who is responsible, accountable, consulted and informed at each stage of the process. So this is for detailed design, which is where we're most going to be looking, is going to be here. So for detailed design, which is where you're going to be having your temporary works design. The key people being your CEM, your CRE, the checker. Wow, and the project engineer now actually as well. So CEM is construction engineers manager. They are the ultimate overseeing person for the scheme. A lot of responsibility being a CEM, often engineering manager type level. They are accountable for most engineering outputs on the scheme. The DPE is a Network Rail role, designated project engineer. So the CEM is normally for the contracting organisation, generally speaking, and looks after all the deliverables and is responsible for making sure that everything is properly coordinated. So making sure the IDCs are undertaken, which is your interdisciplinary checks. CREs, there'll normally be a CRE design for each, what's the word for each, I can't think of the bloody word I want. Each discipline. So you'll probably have one for the OLE, one for temporary works, one for geotechnical, one for permanent works, It all depends on the complexity of the project. You can even have them for demolition. It all depends on how the CEM and how the project team want to set it up. But the CRE design is responsible for making sure that the detailed design is completed. The checker is obviously the checker who's responsible for making sure design check is undertaken. CEM is accountable. They make sure the action is completed, so they got to make sure it's done. The CRE is responsible for performing that task. Okay, and then the project engineer has to accept, i.e. is responsible for accepting that task. I don't know if you can see that with, just clear those sketches. So at the top there, the R, the A, the C, and the I, and what that means. And then the DPE is consulted and has, for acceptance, is accountable as well. All very clearly set out. So you should be under no illusions as to what your role entails. And each of these roles is set down within the Network Rail documentation. I can't remember off the top of my head. I meant to drop in here the correct standard that refers to defining each of these roles. Suffice to say that that has also become a much more in-depth process than it used to be to get approved as a CEM or a CRE or a checker. You have to do a lot more work now to demonstrate that you are competent and that you can undertake that role. It's quite an in-depth process now. A lot more so than when I was talking about this 2 years ago. And it was really just fill in your FO39 or 40, send your CV. Now you've got to do that and your quads and all the other bits and pieces to demonstrate your competence and how you've actually achieved the criteria set down for each of those roles. So to put that into another way to make this a little bit easier to follow, I found it easier to look at it in a flowchart kind of role. So this is how that sits. So for the design, you've got a designer and your checker, and then the CRE is responsible for making sure that this overall design is correct. The DPE is accountable for accepting it, and the CEM is accountable for accepting it. I think I've missed one off there, haven't I? Because I haven't got the project engineer on there. I need to revisit that. No, I need to revisit that. Let's skip that one. Another key item which is now being made a defined requirement is the interdisciplinary check. So that means if you design a piece of temporary works, you've got to do your IDC, which is where all the other disciplines are brought together. You run through the scheme and make sure that your design hasn't or isn't going to affect another discipline's design. So that could be OLE, that could be signal sighting, that could be the gauging team, that could be security, that could be interface with the public in some way. But the idea being that you get everybody in the room, or more likely via Teams or similar, to go through a scheme, and you formally record the output of that assessment. That could include effectively a DRN, a design review notice, which identifies any changes that need to be made. Those changes are then made before the scheme is finalised. But that is now a defined requirement within the Form C and the Form B to make sure that that is done, whereas before it wasn't quite so, not so bluntly put, but it wasn't a requirement, where it's now specifically required on the form. So checking categories. We've seen, if you've watched these webinars before, we've covered these many times. There's Cat 0 to Cat 3, starting with 0, which is the most basic design or most basic design and check package. It's normally for something very, very low hazard. So something like an excavation 1.2 meters deep. Cat 1, slightly more in depth. Cat 2 is where you take another step up in complexity. I'm going to show examples of this shortly, so I'm not going to go into too much detail here. The key change with Cat 2 to Cat 0, Cat 1 being that the person checking the design doesn't get to see the original design calcs, and it can't be someone in the same team So it can be the same organization, but not within the same team. So as a business, we do it by different offices undertake the Cat 2 to the one that's done the design. But it's whatever system you put in place to show that a Cat 2 check is being undertaken properly. The key thing being this point here, which I've said this a number of times, the number of companies I know that still consider that a Cat 2 can be done by looking at the calculations is unbelievable. It says there in black and white, it says in BS 5975 in black and white, you can't look at the calculations. It's as simple as that. Similarly, Cat 3, similar idea, except it goes to another organization. The definition network rail used is a separate legal entity, which, as I understand it, means an entirely separate business, not a part of the business. So if you run with one set of PI cover and you have 3 different businesses with similar name or slightly different names, that is not a separate legal entity because it goes back to the original PI cover. If, however, it's a business and a second business that's completely standalone, separate PI cover, that is what they mean by separate legal entity. The other point with the Cat 3 is the design check methodology and analysis shall be independently derived against the common set of design criteria. So that means that if I was doing a design, I would provide the checker with my design output being the drawings and my design methodology. The checker then has to go away and work out their own methodology. And again, Network Rail would prefer that different software is used, completely different approach is used to demonstrate that from a separate engineer's point of view that the design works. So if we run through some examples now, Cat 0 being the lowest grade. So you've got hoardings that aren't used on the railway, scaffolds to TG20, which means a standard scaffold effectively, ground support for scaffolding or access towers, shallow trenches not exceeding 1.2 meters deep, these sorts of things. So fairly simple run-of-the-mill items. An example there, less than 1.2 meters deep. I mean, that trench box is more than 1.2, but I couldn't find a picture or an image of a trench box 1.2 meters deep, to be honest. So who can do it? Different member of staff to the designer within the same team, and they can look at the calcs, drawings, and any other design output, no problem at all. And the output for Network Rail would be Form H along with the drawings, and they probably want the calc package. If you've got any queries, you can just bring them straight up with the designer. Simple as that. Oh yeah, the trench boxes are available. Cat 1. Simple excavations using Syria 97 trenching practice. Design scaffold to TG20. I'm just pulling out some individual items here. Hoardings greater than 2 meter high, concrete pump out riggers. Hoardings on a platform below 2 meter high. Generally, rail hoardings are 1.8 and on a platform, so that makes sense to me. A Cat 1 check there. Mobile crane outrigger foundations in good ground, cranes 50 ton, rated less than 50 ton. So an example here would be a mobile crane positioned, which is less than a 50 ton mobile crane. So an outrigger load around 25 tons. I'm not going to read all of these out, but again, the output is a Form G for a Cat 1 check or a Cat 1 risk category. And the checker can look at the calculations, the drawings, and go through and make sure that they're happy with the approach. Hoardings, again, this is an interesting one because I've never ever been able to put a hoarding up on a platform that has been Cat 1 checked. They've always had to be minimum of Cat 2 and in some cases Cat 3, but the standard now says Cat 1, though it is at the discretion of the DPE, which is what Civ 003 says. But interesting that this is now classed as a Cat 1 design. Cat 2, where we start getting into the slightly more complex excavation frames, cofferdam, sheet piled walls, contig piled temporary walls, design lifting equipment, barge mounted equipment, tower crane bases and less of complex design. I'm not sure what would define complex design, whether that means a piled base becomes a Cat 3 or whether they mean a grillage. I'm not sure what is defined there. Routine stress cases in the permanent works resulting from temporary conditions becomes under the Cat 2, which is interesting as well. Again, I've never got away with a Cat 2 check where we've changed the loading on a permanent work structure. Conventional tower crane base gets a mention again there, which is interesting. Reinforced soil structures not exceeding 6 meters high. Temporary platforms at Cat 2. Road vehicle bridges and footbridges. Demolition of a single span masonry arch bridge falls under Cat 2 as well. So as an example there, that would fall under a Cat 2 check. Though again, there's many occasions where we've had to do Cat 3 checks of masonry arch bridges. Again, it's down to the DPE to decide. If they decide it warrants a higher level of check, then they're within their rights to ask for a higher level of check. Cat 2, the output is a Form C, a design check statement, and a DRN notice. So if the Cat 2 checker identifies any issues, they should be flagging those up formally to the designer to make sure that they're tracked and they're adjusted or that they're addressed before the design is finalized. And again, the checker cannot look at the calculations. There's no possible way that Cat 2 or Cat 3 checker should be seeing the calculations. It just shouldn't be happening anymore. Excavation like this would be falling under the Cat 2 check category. So this was one we did down in, was it Manor Park? It was Manor Park or Seven Kings. I think it was Manor Park, where we had to do an excavation between 2 tracks. We had OLE here as well. That's not shown in the drawing. We were very, very, very close to the gauging envelope. I haven't updated. This is probably out of date, this reference, but this is a snapshot from the drawing. So this is showing how close we got to the gauging envelope. So that's something you really, really need to consider, particularly when you're doing temporary works in close proximity to the light railway. The gauging envelope is a very important thing. There are ways and means that you can get the gauge envelope reduced, but it's quite a specialist and drawn out process to actually have it gauged for the stock that uses the line. This is the general gauge profile that is used for clearances across the network. But there are certain areas where they have a reduced gauge anyway, but it's not a simple process. It's not one we've ever gone down. It's easier if you stay outside this gauge envelope and then everyone's happy. Cat 3, so the highest hazard temporary works, or the highest or the most complex temporary works you can have on, where we get to things like excavations of cofferdams in tidal conditions, demolition of non-masonry bridges. So any non-masonry bridge has to have a Cat 3 check. Demolition of multi-span masonry arch bridges. Again, that all comes back to a few collapses that have occurred with multi-span masonry arch bridges over the years. Partial demolition or modification of existing structures. Complex or suspended tower crane bases, abnormal stress cases in the permanent works resulting from temporary conditions, any scheme there where you're using the observational method or sensors and monitoring to make sure that it's performing as required. Pile mats and crane mats on poor ground, so that means soft clays, water-bearing soils, loose materials, etc. So there's quite a in-depth description of the things that are covered here. Abnormal and highly innovative designs, work on sensitive clays, facade retentions, schemes close to public areas. And then there's this kind of catch-all of structures that exceed the limits for design check category 2. Any design check category 2 item in an unusual or high-risk situation, innovative or complex designs, projects involving partial demolition, other works that the technical head, AM, or project engineer and the DPE in many cases considered to be in the check category 3. So regardless of how you've categorized it, don't be surprised if Network Rail come back and say, hang on a minute, actually we want you to go to a cat 3 here. It's not unusual at all to be pushed up the ladder. So these categories and the Form C, G and H process applies to when you're working for Network Rail as the ultimate client, but also where you're doing asset protection jobs. So if you're working on a scheme next to the railway, where the end client isn't necessarily Network Rail, you're probably going to have a BAPA in place, which is a basic asset reviewing things. This sequence and all this methodology still applies to those situations. And you will be held to follow these systems. Now, this all applies where you can affect the railway, or the other case is where you can affect the public. So even if you're working on a site that is for Network Rail, just because you can't affect the railway doesn't mean this doesn't apply if a failure can affect the public. If it's totally within your construction site, this doesn't apply. If you can affect the railway, it applies. If you can affect the public, it applies. So it's important that you follow that. You might think, oh, my crane's so far away from the railway that it can't fall on the railway, or my tower crane's not going to affect the railway if it collapses. If it can affect the public and it has a Network Rail interface, that means you're working for Network Rail, or it's through the BAPA process. They will still expect to see this process followed to make sure they're delivering and doing their due diligence as a overall client. So a good example of a Cat 3 would be SAS 13 here. Masonry, multi-span masonry arch bridge being taken down. This again, the output is a Form C design check statement and a DRN notice from the checker to the designer. This is a good example of a Cat 3 as well. I can't remember the exact reason as to why we ended up doing this, but we designed a temporary OLE gantry for Manor Park Station. I think it might have been because they couldn't get hold of stock components. So we designed a temporary OLE gantry, which was installed. And there it is in all its glory. In fact, it's sitting on the lift base that you can see there. That was what the excavation was for back on the earlier slides. So then there's a temporary OLE gantry in place that picked up the OLE. So that was quite an interesting design experience. That not one we've done since, but interesting nonetheless. It only had to last a couple of weeks, I think it was, before the new permanent solution went in place, but it was an interesting one. So bridge demolition is one that is now fully covered in there. This is an example of where we delivered a demolition scheme within Project Wise environment, all in full 3D. Everything, every part of it was done in 3D in the Project Wise environment. Quite hard work and quite a lot of time to get it done, but done it was. The different colors represent the different components of when they come out. Again, we had to get agreement for using the colors in the drawing, but it made it a lot clearer when you were following the demolition sequence to understand what came out when. It's just an example from those drawings showing the propping that was designed and the detail of how we secured the structure and made it safe while the demolition was undertaken. Quite an interesting project. You've probably seen the videos before if you've watched our webinars. Again, considering the adjacent railway, so this section of railway here remained live throughout the demolition works. So we had to take a lot of care with how we planned everything and consider the interface with the live railway throughout and demonstrate that we weren't going to affect it. Excuse me. There's no detail on the propping arrangement there. Another example here of another scheme where 500-ton crane. So just looking at this drawing, the number of temporary works items involved was the crane position, the loads applied to this retaining wall in the temporary case, the demolition of this walkway over here and lifting out this walkway, the track protection down here during the works. There was lots and lots of items involved, and many of them were, I think, in fact, the whole thing was Cat 3 checked. The whole project was Cat 3 checked as one. And this is just a little video I found this morning, actually, when I was looking for a good one. This is a scheme we delivered over Christmas, last Christmas, with John F. Hunt. This is General's Lane, not footbridge, road bridge demolition. It's just a few little clips from the actual finishing off at the end of the shift. It was I think it was a 4-span pre-cast, pre-stressed bridge that was taken down last Christmas in a disruptive possession over, I don't know how many hours it was, 100 hours or something. And there's currently a new bridge going in across there now, which I think Graham's are doing. That wasn't the video I thought it was. That's just showing a cracker. I've managed to insert the wrong video, but there you go. We'll leave it nonetheless. It's quite interesting to see a big cracker going straight through what is a substantial lump of concrete and making it into rubble very quickly. I think there's a better video available on YouTube, but that's one of them. Oh, has that not gone full screen? There we go. So we've talked a few times in some of the descriptions up above of assessment of permanent structures in a temporary condition. We get involved in that quite a lot. So this is a good example of a scheme. This was at not Manor Park. This was at Ilford. That's one. It's just outside Stratford. I can't think of the bloody name. Anyway, there was a temporary case where this existing retaining wall was going to be used in a temporary condition. We had to excavate out here. This had to be excavated, and then a series of piles had to be installed through here for a new lift to be installed. So we had to analyse the structure in the temporary condition, the permanent structure in the temporary condition, to demonstrate that it would work. Again, that was Cat 3 checked, because of the potential for failure was quite significant. And I've talked briefly about asset protection schemes. So that's where you're a private developer building next to a railway, and you've got an app in place to deal with Network Rail to make sure they're happy with the works you're undertaking. So again, you've got to be considering all of the Network Rail assets. So that's not just the railway here, it's not just the lines here, it's not just the OLE gantry that sits here, which isn't shown on this drawing. It's also this retaining wall, which belongs to Network Rail. So in this case, a ground movement assessment was undertaken to demonstrate that in the temporary condition, the retaining wall would not be affected, and also that in the permanent condition, the piles that have been installed back here would not affect Network Rail assets. The reason being the new definition of the track support zone comes out like this and then carries on at 45 degrees infinitely, is the way it's defined within the standard. So if anything you're doing enters that track support zone, you have to demonstrate to Network Rail satisfaction that you are not going to affect the railway. It's quite onerous, and in some cases it seems a bit over the top, particularly in circumstances where you're installing individual piles. This isn't a secant wall or similar. This is just individual piles, but that's the way the standard is written. If you're entering or affecting that track support zone in any way, you have to demonstrate that you're not going to impact the railway. So this is just a little case study of a rail job. Interestingly, although it was over the railway, this wasn't a job for Network Rail. It was an asset protection job. So we were working for TfL, who owned the road. Well, no, we were working for Hockteeth, who were working for TfL, and they had an asset protection agreement in place that Network Rail would review everything and ensure they didn't affect the railway. So it was slightly harder than if you're working direct for Network Rail. This was Network Rail were just the technical authority, as it were, approving and overseeing everything. So that actually shows it in the finished condition, with a new bridge in place, a new road bridge in place, the new service bridge in place, and the revised access to the station. But there were there was two bits of temporary works that really spring to mind. The first one being, if you look here, what you can't see is here, this area here and this area here, we had to build a big, in the end, we chose a king post wall solution around here to put these big chambers in at the back of the service bridge. So this bridge here was to divert the services from what was the old A1 like this. That then allowed this bridge here to be demolished and replaced. You couldn't take this out until the services were diverted. So some of the services in here were BT fibre, and they needed quite big chambers and deep chambers to get from here in the road into here and up to here, which meant we had to put some big old excavations in here, which required a a king post wall around here, went across there, and it went across there. Similar to that anyway. To do that, you needed to be able to get a piling rig in place. We chose a Movax rig, and we were asked to come up with a solution to allow the piling rig to operate up there. Now, if you think about it straight away, you've got a wing wall here from the bridge, and you're going to put quite a chunky excavator. I think it was a 40-ton excavator in the end on here to operate the Movax to drive the king piles in, to then allow the sheeting to be installed, to allow the excavation to be undertaken. So the original design that we were given to work from was that the designers had decided that the best thing to do was to put a big concrete slab in here to try and spread the load out. But there was no consideration of what that would do to this wing wall here, particularly as this wing wall was going to be excavated down in front of it. So we came up with a solution, which was to eliminate the temporary works as much as we could. So you could take out these concrete slabs, reduce it as far as we could, and make them more cost effective. So we said, right, if we put the Navi mat on top of the wall here, that is applying a stabilizing load to the structure. And then if we put the rear stack back here, that load there is not really affecting that wall. It did a little bit, but not much. And that worked really well. No further temporary works were required to stabilize this wall or anything similar. It was as cost effective as it could be, improved the program and reduced the carbon cost of doing the works as well. The other one that was quite interesting was to lift in the service bridge here, that service bridge there. We proposed to stand the mobile crane on top of the abutments, rather than the original proposal was a 500-tonner sitting out on the road here, lifting it into place. We put the 350-ton mobile directly above the abutments. It just happened that the bridge span was just right for it. We got lucky, sometimes you do. And we sat the crane directly above the abutments. We did a AIP for TFL to demonstrate that the abutments could deal with it. We weren't going to affect the bridge. And that gave a much better design output for our client. It's a smaller crane, quicker to rig, and it was actually had more capacity than the 500-tonner would have done, or more percentage capacity left than the 500-tonner would have done sitting up here, reaching to there. So quite, again, reducing temporary works, cost a little bit more on the design side, but overall a better output for the client. And there it is in action. This is the final little case study we've got on a rail interface. This was a project we did for Bowman Kirkland. Again, they had a BAPA in place to deal with Network Rail, and the site in question is here. In fact, it's there. Sorry, it's all that site there. And we were originally involved to provide Cat 3 check-in service for a sheet piled wall and the tower crane base. And in the end, we ended up designing the earth retaining solution and the tower crane base. The reason we overtook I'll show you why we ended up the designer for the sheet pile wall shortly, and a tower crane. It had to be interfaced rather than a simple base. We had to interface it with the permanent works. And we ended up taking design responsibility and doing the full network rail submission and acting as CRED on the scheme for them in the end. So that's the site. You can see up here, you've got the railway line there sitting on top of an embankment and the OLE, and the final wall position is somewhere here, somewhere like that, that we need to achieve. So we receive this as the design to check. So nothing that puts it in context on the site, really shows where the railway sits in relation to it. And they hadn't really considered the site constraints at all, or even the drivability and the constructability of their design. So, and when we did our check, we found they clearly hadn't allowed for the surcharge from the railway. Deflections of over 65 mil at the top here, which would have led to deflections in the embankment, which should have led to movement in the track on the top, which are all things you want to try and avoid when you're doing a rail job. And sheets that are supposed to be driven into mudstone, into fairly stiff mudstone as well, which just wasn't feasible with the size of rig that they could get on the site. So we found that the Cat 3 check failed, and Bowman's asked us to redesign, come up with a solution that actually worked on the project. So you can see up here, this is the rail embankment there. So you've got your rail loadings to take into account. And again, you're affecting quite clearly the track support zone, which would end up something like this. That would be your track support zone somewhere there. So you can see it's not a massive load really on the back of the sheet pile walls, but it still needs to be considered. And you need to demonstrate why it is that you're not affecting network rail's assets, and particularly make sure you're considering deflection of those sheet piles, because any deflection here is going to lead to settlement up here. So our whole process was designed around this concept of how do we install the piles. We can't put them into the mudstone because we know the rig can't drive them. So we had to be able to drive these sheets. They were only 7 meter sheets in the end, and then prop it whilst maintaining stability of the embankment. That propping then allowed you to take out the remaining permanent works. Then you could install the new permanent works. Then you could backfill between the permanent works and the wall, and away you go. So you can see how the original design provided one part of the solution, but didn't consider how the whole scheme will be delivered. Part of the problem when you push the designs down and down the supply chain. So the person doing the design was working purely for the piling contractor. They wouldn't have thought that, given the fact they ignored the fact you couldn't drive in the mudstone. Whereas if you come to us, you get the full solution, which covers the whole project there, from install those sheets, interface the railway, to getting a solution that works at the end of it, but works holistically on the project, not just locally for one aspect. And there's the design in principle. We also used a return corner up here off the permanent works to prop that end. So wherever we can, we use things that are already going to be installed to make sure that the scheme is the best that it can be overall for a client. I don't know why I've got a blank page there. There you go. And this is just a little video of that site being installed. This is Muirstone going in. Yeah, it's quite a compact little site and quite a lot to be built in there. You can see the ground beams going in down there. Quite a difficult site to manage logistically, I would have thought. And there's the sheets gone in, propping going in. Permanent works going in. And there you go, backfill, pull the sheets, job done. Well, you can see they really did use every inch, every available inch of that site to maximise the build for their client. That scheme is now finished. I think there might even be people in it now. Why can't I get out of this video now? Okay, right. So as I said, any questions in Q&A, fire it into the Q&A function and we'll take questions shortly. The Safe by Design document by Network Rail is well worth reading. Steve Williams, if he's listening, would not let me get away with failing to mention that. The Temporary Works Forum as well, always worth a look. There's lots and lots and lots of guidance documents produced by the Temporary Works Forum that cover a lot of aspects of temporary works. Well worth a look.